Hi viewers, welcome to my class on mechanics of materials. In today's class, we'll work out a numerical example to calculate the volumetric strain of a rectangular block when subjected to loading. So let us start. Find the change in dimensions and the change in volume of a rectangular block due to the loads shown in figure. Young's modulus E is equal to 195 gigapascal and Poisson's ratio is 0.3. So block is subjected to load in x direction and y direction. In z direction no load is acting. So x direction 60 kilonewton is acting, y direction 30 kilonewton. So x direction the load is tensile 60 kilonewton tensile, and y direction the load is compressive. So both the forces are acting towards the block, so it's compressive, 30 kilonewton compressive. And the dimensions of the block is in x direction 150 mm, y direction 100 mm, and z direction, and the block has 80 mm. If you take x, y, z as the dimensions of the block, x is 150, y is 100, and z is 80. Let us calculate the stress in x and y direction. Now load in x direction is 60 kilonewton tensile, so plus 60 into 10 raised to 3 Newton converted into Newton. So kilonewton to Newton, you need to multiply by 10 raised to 3. In y direction the load is minus because it's compressive, so minus 30 kilonewton or minus 30 into 10 raised to 3 Newton. In z direction there is no load, so Pz is 0. So correspondingly you can find out the stress in x direction, y direction and z direction. In z direction there is no load. Since there is no load, it is directly you can take it as 0. In x direction, the load in x direction divided by area resisting in the x direction. Okay. Load in x direction is 60 kilonewton, so 60 into 10 raised to 3 divided by area which resists that load is this blue colored face. Okay, that is area normal to this force. So it is y into z. Y is the vertical distance and z is the distance perpendicular to the screen. So it is 100 into 80. Okay, y is 100, z is 80. So it is 100 into 80. So 60 into 10 raised to 3 divided by 100 into 80, which gives 7.5 megapascal. You get Newton per mm square, which is equal to megapascal. So it is load is in Newton and area is in mm square. So you are getting 7.5 Newton per mm square, which can be written as 7.5 megapascal. Load in y direction is 30 kilonewton compressive, so minus 30 into 10 raised to 3, okay, divided by area resisting this load. Area resisting this load is this orange colored face. It is lying in the horizontal plane. This orange colored face area is, this dimension is 150 into 80, that is x into z, x dimension into z dimension. So 150 into 80, which gives the area resisting load in y direction. That is the area which is lying perpendicular to this force, and that is resisting this force. So minus 30 into 10 raised to 3 divided by 150 into 80, which gives minus 2.5 megapascal. So the stress is compressive. Minus sign indicates it's compressive. So when tensile and compressive loads are there, you need to take the sign convention. Always when you use generalized Hooke's law, you can use the sign convention. Okay. Sigma z is 0. Since no load in z direction, you can take sigma z as 0. Now you can find out the strain in x direction. Strain in x direction is sigma x by E minus mu sigma y by E minus mu sigma z by E. This is a part of generalized Hooke's law. You have strain in x, y, z direction. So I written that strain in x direction. So 1 by E into E is taken outside into sigma x minus mu sigma y minus mu sigma z. E is 195 gigapascal. So 195 into 10 raised to 3 Newton per mm square. It's converted from gigapascal to Newton per mm square. and sigma x is 7.5 megapascal. Sigma y we got minus 2.5. Nu is 0.3. Sigma y is minus 2.5. So minus of minus will make it plus. That term plus. So 0.3 into minus 2.5 minus of minus plus. So plus 0.3 into 2.5. And sigma set is 0. So third term is 0. Now which works out to 4.2308 into 10 raised to minus 5. So this is strain in x direction. That means increase in length in x direction in unit length. So much mm will be the increase in 1 mm length in x direction. Increase I said because it is positive. Since you are getting the strain positive, so this is the increase in length in unit length of the block in x direction. So in 1 mm length of the block in that direction, x direction, 1 mm length, so much mm, that is 4.23 into 10 raised to minus 5 mm will be the increase in length. So in total 150 mm, this is in 1 mm so much mm. In 150 mm the increase will be, you have to multiply this in unit length so much distance. Okay, whatever unit you take, if you take that length unit as mm, in unit length 4.2308 into 10 raised to minus 5 mm will be the increase. So in 150 mm you can get, you have to multiply strain with the distance in x direction. So you get 0.0635 mm as the increase in length in the x direction. So the block dimension in x direction will increase by this amount. Now similarly, strain in y direction, you can use the formula sigma y by E, which is a direct strain in y direction due to the load in y direction. Okay, and lateral strain due to load in z direction, but there is no load in z direction, this will become 0. This is a lateral strain induced in y direction due to stress in x direction. Stress in x direction, that is load is acting in x direction, that will induce a strain in y direction, because you are pulling it in x direction, that will try to decrease the dimension in y direction. Okay, so minus nu sigma x by E. This is lateral strain induced in y direction due to load in x direction, whereas this is a direct strain in y direction due to load in y direction. So direct strain due to load in y direction and lateral strain induced in y direction due to load in x direction. So Ey will get 1 by E into sigma y minus nu sigma z minus nu sigma x. Sigma z is 0, this term is 0. Sigma y is negative, so minus 2.5, and sigma x is 7.5, nu is 0.3. So substituting that, both terms are negative, so you get totally a negative strain. Young's modulus is 195 into 10 raised to 3 after conversion gigapascal to Newton per mm square. So much is the strain in y direction, and minus sign indicates there is a reduction in length in the y direction. The block dimension is decreasing in y direction. So 2.4359 into 10 raised to minus 5 is a strain. Strain means so much is a change in length in unit length. If you take the unit of length as mm, the decrease in length in y direction is 2.4359 into 10 raised to minus 5 mm in every mm. So in 1 mm, 1 mm length in y direction, 2.4359 into 10 raised to minus 5 mm will be the decrease. So in 100 mm, totally 100 mm length is there. 100 mm length, the decrease is going to be so much. So minus 0.000244 mm. That will be the decrease in length in y direction. So in the block dimension was 100. Now it will be less than 100. Okay. So much decrease will take place in y direction. Now let us find out the strain in z direction. So no load is acting in z direction, but the loads which are acting in x and y direction will induce strain in z direction. This pull is trying to decrease the length in z direction. Okay, this compressive load is trying to bulge the or increase the length in z direction. So there are two effects, opposite effects. X direction load is trying to decrease the length in z direction because it's a tensile force, whereas y direction load, 30 kilonewton compressive load, is trying to increase the length in z direction. So these two are opposite effects, will ultimately make some positive or negative strain in z direction. Now z direction, strain in z direction is, you can apply the formula sigma z by no stress in z direction, so this term will be 0, and both are lateral effects due to load in x and y direction. So due to load in x and y direction, it will have an effect in z direction, that is a strain in z direction. So lateral strains induced due to forces in x and y direction. So minus nu sigma x by E minus nu sigma y by E will be the strain in z direction. So 1 by E into sigma z minus nu sigma x minus nu sigma y. Sigma z is 0, sigma x is 7.5, we can substitute. Sigma y is minus 2.5, so minus makes this term plus, and nu is 0.3, and E is 195 gigapascal, so in 195 into 10 raised to 3, so it works out to minus value. This minus sign indicates compressive strain or decreasing dimension in z direction, and the value is 7.692 into 10 raised to minus 6 mm per mm. You can take so much mm in unit length. So strain means change in length in unit length. So in 1 mm length in z direction, 7.692 into 10 raised to minus 6 mm will be the decrease in length. So in 80 mm length, the decrease will be, you have to multiply by 80 and you get minus 0.0006154 mm. So in z direction, the block dimension will decrease by this amount. Now volumetric strain, you can use EV is equal to EX plus EY plus EZ. So you already studied that expression for volumetric strain of a block, whether it's a block or any geometrical shape. If you add strain in x, y, z direction, which will give the volumetric strain. So you already got strain in x, y, z direction. You can add that strain in x, y and z direction, which will give the volumetric strain. Or you can also use a reduced formula for like this. So Ex, if you substitute sigma x by E minus nu sigma y by E minus nu sigma z by E. Similarly, Ey also you can substitute, Ez also you can substitute the formula and reduce, you will get a volumetric strain expression like this. You can take it as a homework, substitute Ex, Ey, Ez in terms of stresses, Young's modulus and Poisson's ratio. The three expressions derived as a part of generalized Hooke's law, you can substitute and reduce the volumetric strain expression. It is only direct substitution and reducing the terms. If you add, you will get this generalized expression for volumetric strain. So you can also use, if only you have to find out the volumetric strain, you can find out the volumetric strain directly by using this formula. Okay, so this will be easy for you to find out the volumetric strain if only volumetric strain is asked. Whereas if you have to find out all the three strains and change in dimension of the block in x, y, z direction, you have to you can use this formula to find out the volumetric strain. So you got the volumetric strain. This is a change in volume in unit volume. So now unit for this. Now change in volume of the block you can find out as volumetric strain into volume of the block. So volumetric strain is 1.0257 into 10 raised to minus 5. The dimensions of the block is 150 into 100 into 80. So 100 into 80 will give this area, into length is 150, which will give the volume. For a block like this, if you multiply all the dimensions, x, y, z dimensions, which will give the volume of the block. So initial volume is 150 into 100 into 80. So if you multiply all this, you will get the volume. So into volumetric strain, which will give the change in volume as 12.3084 mm3. So this is a change in volume of the block. Since you are getting a positive sign, volume is increasing by this amount. Initial volume was 150 into 100 into 80 mm3. Increase in volume after subjecting to the load, the volume will increase by this amount. So whatever volume you had before subjecting the load plus this volume will be the final volume of the block. That's all for today. Thank you for watching.